First of all, what we'll do is we'll download and then install our VirtualBox application. So we go to the virtualbox.org website, and when we reach that page, we'll see a nice big button to download the latest version. When we click that button, we're taken to a page where we can select the operating system that we wish to download VirtualBox for installation onto. Since I'm going to be installing VirtualBox on a Windows machine, I select the AMD 64 download, and that starts downloading VirtualBox. While we're here, we also want to install the VirtualBox extension pack. So I pick the link here to download the all supported platforms version, and this will download for a few minutes. Once the components have downloaded, I then move them to a separate directory so that I can install them. The VirtualBox installer is very easy to operate. We just execute the installer. It opens up a dialog. Clicks for a few minutes. We'll work through this. I'm not changing any of the default parameters, leaving everything as the default. Begin the installation. Yes, do the installation. We'll get a few prompts while the installation cooks. It doesn't take that long, so I'm just going to walk us through all the steps. So it's copying the new files. It's asking us if we want to install device drivers on our host OS. That will be Windows. This is going to be yes. These are the device drivers that bridge from the host OS to the guest. And that's it. Now at this point, at the end of the installation, it wants to launch VirtualBox. Unselect that. Don't launch it immediately. And instead, we can go to the extension pack, launch the extension pack, and that will then prompt us to install the extra extensions for VirtualBox. These are the extensions which allow us to access USB devices and other good things. Doesn't take long to run those, and that is the installation of VirtualBox. With VirtualBox installed on our machine, the next task in front of us is to install a Linux operating system as a guest on VirtualBox. The version of Linux I've chosen is Ubuntu, and we'll download the desktop version of that. So that's www.ubuntu.com download/desktop, and at the time of recording this, the latest version is 15.10. So click the download button, and that will start to download, or in a moment that will take us to the download, and in a few seconds we will start to download this beast. Now notice it's a large 1.1 gigabyte file, so obviously that will take a while. So go grab a cup of coffee and we'll come back when it's downloaded. After having downloaded the image for Ubuntu, what we can do now is go ahead and install it. So I've copied the image into my installation images folder. If we now bring up VirtualBox, click the new button, give it a name for the image we want to build, and this will be my ESP8266. The operating system type will be a Linux machine, and the version of Linux will be 64-bit Ubuntu. Hit the next button. How much RAM do I want? Well, I'm going to allocate 2 gigabytes. That's all we need for just now. We can always increase that later. And now, do we want to create a virtual hard disk? Yes. Hit the create button. We want it to be a VirtualBox disk image. Yes. Dynamically allocated. Yes. And this is very important. This is how much disk space do we want to allocate for the default disk. Now the default is 8 gig. That's not enough. I recommend 20 gig. 20 gigabytes. Oop, I seem to have got a typo in there. Let's see, 20 gigabytes. Yep. Hit the create button, and now we have a virtual machine called ESP8266, which is powered off. Now before we boot it, we'll do that shortly, but before we boot it, let's make some changes. First of all, I don't need any audio, so I am going to disable the audio. USB, I'm going to switch on USB 2.0. That's great. That's what I want. Let's see, anything else? Memory. Oh, and under the system environment, I happen to have 4 processors. I've got a nice quad core in mine. You can match that to yours, but I've got 4 cores on mine. Now we're at the point where we can start the image, and when we request it to start, it'll boot, but it will tell us it will ask us where we want to load the operating system from. So I'm going to now browse, and I'm going to select my Ubuntu file and hit the start button. And now what's happening is VirtualBox is booting itself for the first time, and it's going to use the Ubuntu ISO file that we downloaded, which is the installation image for Ubuntu, and it's going to install that into our new virtual machine that we've just created. So this will take a few minutes. I'll go ahead and record what it is we're doing here. So it's asking us, do we want to install it? Yes, go ahead and install Ubuntu. Do we have the right requisites? Yes, 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 and yes. Hit the continue button. Erase the disk. Now remember, this is the virtual disk. This is not your real hard disk. This is why we're working with virtual machines. So this is your virtual disk. And yes, continue. Asking for my time zone. That will work for me. That's where I am. Keyboard layout. Yep. And my user ID. So I'm going to give myself a user ID of Colban, and for my password I'm going to select password, and I want to log in automatically and continue. And now what's happening is the image is being built. It's copying the ISO files from the input media, and it's building me a virtual image of a Linux machine. So this is going to take a few moments to complete. There's nothing to do but just sit and watch and wait and watch Ubuntu install. Now that Ubuntu has installed, it's telling us that we need to restart to complete. So I hit the restart button. And as we see here, we got some error. So what I'm going to do is I'm just going to close that down, power off that machine, and now I'm just going to boot it normally. And what we have now is a Virgin Ubuntu environment. So we are at the stage now where we've created ourselves a virtual box, and on that virtual box we have loaded Ubuntu and everything is good. Now there's one more thing that we have to do, and that is we need to install the additional guest CD images. These are applications that run inside the guest which make VirtualBox more usable. So we select that. It's asking us, do we want to run these additions? Yes, we do. It's asking for my Unix password, or my Ubuntu password, and it's now installing the additional goodies for VirtualBox, which get installed at the application level on the Ubuntu environment. And upon completion of the extra goodies, it's telling us that we're completed, so we can now hit the enter key and close that work. The CD-ROM that is the virtual edition still shows up here, so we can eject that. We're no longer going to need that. And even though it wasn't a real physical CD-ROM, it's now been ejected. And we now have an environment which is going to form the basis for the rest of our ESP8266 work. With our Ubuntu environment now ready to go, it's time to start thinking about installing the ESP development kit, the ESP8266 development environment. Now, this is where the tricky stuff comes in. So the first thing we're going to do is we're going to need ourselves a Unix command terminal. And I'm going to put my Ubuntu up to full screen. Or I'm going to try to. And as we see, that just nicely locks up my machine. Whoop, there we go. Now it works. So we've got our Ubuntu up at full screen. And I'm going to open up a terminal. So let's open up a terminal window. And I'm in my user's home directory. And to perform the installation of the ESP8266 development kit, one of the first things we've got to do is we've got to install some development tools that don't come by default with an Ubuntu distribution. So I've got a little cheat sheet here where in my files, nope, not cat ls, where I've got a file called data.txt where I keep my cheat sheet material, and this is the command that I want to run. Now I'll put this in the YouTube link as well, but this is the command which allows us to install the tools which aren't supplied by default. So I'll copy this, I'll paste this into the command line. And since it's a sudo command, it needs my password, and it's cooking. So what this is doing is this is installing a bunch of additional development tools by going out onto the internet, finding those tools, downloading them, and then installing them. At the conclusion of this, we'll have the development tools which are necessary for building the ESP8266 development environment. Okay, so that's completed. Now let's go back to our cheat sheet here, cat data.txt, and the next command we're going to do is to actually download the development kit. Now I want to do that in my own directory, so I'm going to create a directory called ESP8266. I'm going to change into ESP8266, and then I'm going to run this git clone command. This is going to clone from GitHub the development tooling. So this is going to take a few minutes to run. Okay, that didn't take much time at all. And the result of this will be this directory, which is the ESP Open SDK, and contained within there is the source code of the tool chain necessary for building ESP8266 binaries, as well as the libraries needed to link those applications together. So we'll change into the ESP Open SDK directory, and in here we've got a make file. Now we've got two choices in running the make file. One is to embed the development kit with the libraries of the tooling, but I choose not to do that. I want to keep them separate. So I'm going to run make standalone equals y for yes, and hit the enter key. And now, oh, apparently this is going to fail. So why did that fail? Sorry about that. Turns out that there's another package that needed to be installed. It's called libtool-bin. So we need to add sudo apt-get install libtool-bin into our list of commands. That installs another one of the prereqs necessary for compilation, and this time we can do make stand alone equals yes. And now it's going to cook all the way through. So the compilation of the build toolchain, of the toolchain necessary for compiling ESP8266 applications takes at least an hour to complete. So this is a great time. Go get some dinner, come back in the morning, and I'm going to pause the recording here and we'll come back when the compilation is completed. And about an hour later, we have the toolchain built. So let's see what this built for us. As I say, the compilation all completed. If we now bring up a file browser and we go into the ESP8266 folder, then into the OpenSDK. There are two folders which are of interest to us. One is this folder called SDK, and the other is this tool called Extensa LX106ELF. Now, this folder, Extensa LX106ELF, is what includes a bin folder, and it is the bin folder which contains all the executables we'll need, including the C compiler, the linker, the debugger, the ESPTool, and a whole bunch of others. The SDK directory contains within it a link to all of the Espressif supplied libraries, which are the libraries which we link our application code together with. Alright, so this has demonstrated that the compilation of the toolchain has completed. Now there's a couple more things that we do. First of all, we go find the bin directory where the binaries were built. I take a copy of the path, and then I go to my home directory and I'm going to edit my profile. Because what I want to do is I want to add into my user's profile the path to the binaries. So let's open a new, let's open out the editor and say path equals $path : and then let's paste in the directory. Okay, so this adds the ESP8266 Extensa LX106ELF bin into my application path. And I also want to set up an environment variable, ESP8266 SDK root, and I want to point that to the directory which is the SDK directory. Again, I'll copy that. I'll go back to my editor, wherever I had it. There it is. I'll paste that in, and I'll export that environment variable. Export ESP8266 SDK root, and that looks great. So I'll save this, close the editor, and for the profile to take effect, I'm going to log out and log back in again. So the easiest way to log out is to come here, come here, log out, and then we can log back in again. And of course that will cause our profile to be run. Looks like I've got something wrong in my profile. What did I get wrong in my profile? Let's see what kind of an error I made. So let's bring up a terminal again. I'm sure I made some dumb mistake. Let's bring up a terminal again. And let's look at my profile. I'm sure I made some dumb mistake. Oh, look at that, export. That's not right. That's not right. It's export. Export. So save that. Close that. Relog out. Yes, log out. Sorry about that, chums. Log back in again, and we shouldn't have an error this time. Good. And now we're ready for the next part of our story. The next thing we're going to do is we're going to prepare for the installation of our development environment, our integrated development environment. For us, that's going to be Eclipse, and Eclipse is a Java-based application. So before we can install IDE, we need to install the Java runtime. So bring up a browser. I'm using Firefox here. Go to java.com. Hit the 3 download button. Download the appropriate Java runtime. For me, that's this fella. Save the file. Alright, downloads, click. And that's now downloaded. Done. Open up my file browser. No, that's not my file browser. Open up my file browser. Go into the downloads folder. And there's my file. Now, what I'm now going to do is I'm going to open up a terminal window. And I'm going to change directory to the user folder. I'm going to sudo a shell, so become root. Password. So I'm now a root user ID. I'm going to make directory Java. I'm going to change into the Java folder. Copy ~/downloads /* to here. We've now copied in the JRE from here, which we just downloaded. And now I'm going to extract this tar zxvf, this file, extracted all that yummy goodness, and now we have the installed directory. So I don't need that gzip file anymore, and I don't need to be root anymore. And we now have a extracted version of the Java runtime in my environment. If we bring up a browser and go to the user Java folder and then into JRE, here's our bin and other components. So now we want to once more edit our profile, change to my home directory, gedit my profile, and we want to add in java_home equals this directory. Let's copy this, paste that there. Yep, that looks good. And export java_home, and finally add in the bin folder into our class, and not class path, into our path statement, so it can find the Java executables for the runtime. Save that, and we're good. So now if I close this editor, I've saved this, close this editor, close these other components, and once again restart, or log out rather, log out and log back in again, we should find that we now have a Java environment ready for us. And I can validate that by once again bringing up a terminal window and typing in Java -version, and oh, that didn't work, did it? Let's see. Oh, I know what I did. I made a mistake in my profile. So let's go ahead, gedit.profile. Gosh, making mistakes all over the place today. So here is there. I added my bin here. I added that not onto my path variable that I wanted to do. So let's Control X, Control V, there we go. I added it onto this environment variable and not onto my path. Duh. So save that, log out of this, log out of my environment, log out, and then log back in again, and bring up a terminal, and all going well. This time, when we run Java -version, we will now find that we have the latest Java installed. Hoorah! And now we can start looking at installing Eclipse. To install Eclipse, we'll again bring up a browser, and we will go to the URL eclipse.org/ downloads. And from there, we can find that we have an Eclipse installer. So I'll download the 64-bit Eclipse installer and make this window a little bit bigger so we can see, and click download and save the file. Yuppers. And it's now downloading this large file. So that could take a minute or so, so we'll come back in a minute. And about a minute later, we have completed our download. So if I now bring up my file manager, go into my downloads folder. Here is my Eclipse installer. So let's extract that. Extract it to here. Go into the Eclipse installer folder, and here's the Eclipse installer executable. So select run. It executes the Eclipse installer, and now we get to walk through the Eclipse installation wizard. So what we want to do is we want to install the Eclipse IDE for C and C++ developers. Click. It specifies our home directory Eclipse C++ Mars. That's perfect. That's what I want. Install. Click. And now it's going to perform an installation for us. We accept the licenses. Yep. And it whirs and it clicks as it installs Eclipse. And then sometime later, a couple of minutes, we get the message that it has completed its installation. So we hit the launch button, and for the first time, up comes our Eclipse environment. Now when Eclipse starts, it wants a workspace, and we'll default the workspace into our home directory. And first launch, up comes Eclipse, and here is our Eclipse development environment. Oh, isn't that nice? Now I'm going to pin Eclipse onto the launcher so that whenever we start our Linux environment, that will be there. I'm also going to pin a terminal onto our launcher. And now we are ready to begin the development of our solutions, our ESP8266 solutions. We have our development environment built. Now, once we've built our application, which we haven't covered yet, we're going to want to flash that to our ESP8266 device. Now, there's a particularly good tool which I like to use. It's called ESPTool-CK, and that is available on GitHub. So we bring up a browser, and I've got a cheat sheet here of, no, not here. Not here. I've got a cheat sheet available here, which contains my links, and this is where we get the file for download. So let me bring up that URL, and from here we can download the 64-bit version of that executable and save it. Yep, so we've downloaded that file. And there it is here. Let me extract it to this folder. And there it is. This is the binary. I'm now going to copy that file, and I'm going to copy it into the ESP8266 SDK bin folder. This is where I want to place it. So I guess I copy bin and say paste into folder, and we should have ESPTool in that folder now. Now this is a binary which, as I say, is excellent for flashing binary data into the running ESP8266, well, not to running, into the ESP8266 environment. Now we're now ready to build our sample application. Now, rather than type in all that dross, what we're going to do is we're going to bring in a pre-built sample from GitHub using Eclipse. So we go to our Eclipse environment, we open a perspective on Eclipse. Oh, it's easier said than done. I'm trying to remember how I do that. Let's see. Oh, I remember now. Yes, we select Eclipse, we go up here, we change to the perspective called Git. There it is. We go to the Git perspective. We say we want to clone a Git repository. Disable that. Yep. We want to clone a Git repository. Let's pick this URL, which is the URL to the repository on GitHub, and paste it here, and hit the next button, and that will have downloaded the Git project into our environment, and we can now add that project that's been downloaded from Git as a project in Eclipse. Hit the finish button, click, and then switch back to the C and C++ perspective, and we will now find that we have a sample project ready for compilation. And this sample project includes a simple main file, and the main file does nothing more than print the word hello. So next we'll look at how we go about compiling that. Now, before we go too much further, there is a couple of other tasks that we need to do, which are one-time tasks, which, to be honest, I forgot about. We need to install a serial terminal emulator, and the one that I suggest is a tool called the GTK-term. So if we go to, where will it be, here, to load additional software, and go search for GTK-term and let it run. There is the application. Select install. It goes away and it clicks and it whirs. Enter your password so that it's got root authority to perform the installation. It whirs and it clicks for a little bit, and at the end of that we have our serial port terminal emulator. Now when we run that, that will allow us to basically be a terminal emulator against the serial port. But what serial port? Well, the ESP8266 is connected via a USB to UART connector, which appears plugged into my Windows system. Now I can transfer that through here by clicking, normally it will be here, and that adds my device, and my device then appears as a dev device /dev list TTY USB 0 is what it shows up as. There we go. Unfortunately, we don't have access to it. It's owned by root and it's readable by a user in the dial-out group. But if we look at my user ID, we'll notice very quickly that I am not a user of the dial-out group. So one of the things we should do is we should add ourselves to the dial-out group. So sudo user mod -a -g, the group dial-out, and then your user ID. And run, click, enter the password. Ooh, sorry, got my password wrong. Run it again. Yep. And now am I a member of? No. So I would have to apparently log out and log back in again in order for that to take effect. So let me do that real quick. Shut down this, exit Eclipse, log out of this, bring out, log out of my user ID. You get to do this a lot in Unix. And log back in again, log in, and now if all has gone well, my user ID should be a member of the dial-out group, which means that under the dev ls-l tty USB 0, I can now read and write through the dial-out port. The dial-out port, of course, is TTY USB 0. That's the USB port, which leads and points to my ESP8266. Let's bring up my Eclipse environment again and open my workspace. And now we've got a moment of truth. We should be about ready to rock and roll. So bear with me a second. So here we go. So when we run this program, it's going to print to the debug log of the ESP8266 the word hello. Now to compile a program, if we go to our makefile parameters, make targets, and expand here, we have a command called all, and that compiles the code. And literally, this is ridiculously fast to compile. Let me clean it. So there's no code, compile, boom, compiled. Literally as fast as that. Now, when we run the flash script, what that's going to do is that is now flashing to the ESP8266 this compiled program, this program that we have just written here. And let that cook for a few moments. It takes about a minute or two to push a whole application, even this application, to the ESP8266. And once done, it's done. And now we want to add a second, what's the word I want to use? A second bridge. Oh, sorry about that. I'd forgotten to install a device driver for my USB, so I now have two USBs attached, one for flashing and one for the debug port. So let us bring up the serial port terminal emulator, and when we bring it up, it tells us no, we failed, but it created a file called .gtk termrc. This is the configuration file for this tool. So let's shut that down again. Let's go back to the home directory of my user. My home directory here. Hit Control H to see hidden files. Scroll down. Here's the termrc file. Edit that, and we find in here the port we should use, and we're going to use TTY USB 1. USB 0 is the one I use to flash my ESP8266. USB 1 is my debug port, and set that with a baud rate of 15200. Nice good baud speed. Close that, save it, and now the moment of truth. We bring up my terminal emulator and we see nothing. Why do we see nothing? Because the program already ran. Now, I'm physically reaching over to my ESP8266 and I'm hitting the reset button. I hit the reset button and we see the word hello. And then some other debug, but notice the word hello. Where did hello come from? This was my C code. So let's change this from hello to hello world. And go back to my make target and reflash it. It compiles the program and reflashes it. We can see the flashing taking place on the debug port. So it's reflashing the ESP8266 after having changed the code, after having recompiled it. It's reflashing it, it's reflashing it. I'm just filling space for the next 30%, 20%, 10%. And once it's reflashed, we see the text is now hello world. So this is demonstrated that we can now code within a C source application. We can change the code of that C source application and we compile it. So let's review what we've done, because this is bringing us to the end of this presentation. From nothing, we downloaded VirtualBox. We downloaded Ubuntu. We created a VirtualBox instance from Ubuntu. Within the Ubuntu environment, we then installed some of the additional development tools. We then downloaded the source code for the tool chain for the compiler for ESP8266. We compiled the whole tool chain, which gives us a compiler which runs on Linux and generates ESP8266 binaries. We then downloaded the Java runtime environment. We then downloaded Eclipse. We installed Eclipse. We then downloaded a sample application. We compiled the sample application. We then downloaded a serial emulator. We added our USB ports. We compiled the application. we flashed it to our ESP8266, we rebooted the ESP8266, and we attached the terminal emulator to it, and we can see that the code changes we've made have now resulted in running code. So from nothing, we now have a development environment which allows us to build C-based applications and deploy them to the ESP8266. And that's it. Thank you for your time, guys. Long video. Appreciate it. Bye for now.